This is Goddess of Science Physics, and I'm Mrs. Bolvin. Today we're actually going to talk about Newton's third law of motion. It's of the three, it's probably the easiest one. This is part 2 of my Newton's third law series. Okay, so Newton's third law covers the relationship between two forces that are in an interaction. In the last video, we learned what an interaction was. So scientists have to name every God blessed thing. So one of the forces in the interaction we're going to call the action force, and the other force is going to be called the reaction force. Neither force can exist without the other force. The forces are always in pairs, much like when we had the force of gravity and a support force acting on a mug that was sitting on my desk, when we talked about that when we were doing free body diagrams. So here's the thing. The two forces, the action force and the reaction force, are equal in strength and opposite in direction. And they occur at exactly the same time. So they occur at the same time, equal and opposite. One force is the action force, the other force is the reaction force. Okay, so Newton's third law is often stated: to every action there is an equal and opposing reaction. So it doesn't really matter which force you call the action and which one you call the reaction, as long as one is one and one is the other. So they always occur in pairs. If you push against the floor pushes against you. The tires of a car interact with the road to produce the car's motion. The tires push against the road pushes back on the tires, and you move forward. When you're swimming, you push the water backward and the water pushes you forward. Get where I'm going with these? So these interactions, these examples all depend upon the force of friction. So a person trying to walk on ice, where force of friction is really, really small, they're only able to exert a very small action force against the ice. They have, because the two forces, the action and the reaction force, have to be equal, they're only going to get a small reaction force, which is actually going to move them forward when they're trying to walk on ice. Small action force, only a small reaction force, so there's going to be very minimal forward motion. So another fun example of action-reaction is the dog wags the tail and the tail wags the dog. You probably have seen dogs that get so excited that they're wagging their tail so hard that their butt starts wagging as well. So that's kind of an example of that. Well, that's it for Newton's third law for today. Thanks for joining me. Have a great day.